This problem looked really hard, so I thought we'd try it. And we're at the end of the implicit differentiation lesson. We've been doing tangent lines, so I think that's where they're leaning with this. And they say, find the height of this lamp. If it casts a shadow that goes right to negative 5, 0 here. That's what they want. And I suppose you could do it down here too if you wanted. But we don't know this point here, so I'd like to go at this point here. And in order to do that, it's going to take a little bit of work, but I think we can do it. The first thing I want to make sure we understand is the ellipse itself, this guy here, is x squared plus 4y squared equals 5. And I'm just going to rearrange that to say y squared equals 5 minus x squared over 4. Because a lot of times we need to plug in for y's, and I can do a square root if I need to, but for now we'll just leave it that way. You know, the other thing we can do is appreciate that this lamp is at an x value of 3, and then its height is what we're looking for. So we just want to keep that in mind. And what else do we know? I think we're going to need to find this tangent line, which goes through negative 5, 0 here, to kind of figure this out. But beyond that, I think we just need to differentiate. So let's take the derivative of the ellipse itself. That's going to be like 2x plus 8y dy dx equals 0. Now you should be able to do this already before coming to this problem. This is like number 12 in the problem set on my example playlist alone. So you should get dy dx equals negative 2x over 8y. And we're going to say that that means that it is negative x over 4y. I think that's right. So here's 1. I'm going to circle the things that are important here. Here's 1. Here's 1. And that's great because we've found anywhere on this ellipse we can find the slope. Doesn't matter where we are on the ellipse, we have found that. That's what this dy dx equation tells us. The problem, of course, is we don't know, this is what we want here, we don't know what that x value is yet, do we? So we have the formula, but we don't have a way to put it in just yet. And I thought, you know, we would play around with it just a little bit more and maybe we can come to an understanding. And I thought, well, this line here, we need this line. But we don't know what this point is exactly. What I do know is that the tangent line somewhere on this ellipse and the tangent line here will cross at like one important part right here that we can use. And we have the formula for the slope in the ellipse. So if we can find the formula for this slope, we should be able to find where they intersect. That's my theory. And slope is y2 minus y1 over x2 minus x1. This is algebra from back in the day. Real slope, right? Not this derivative stuff yet. But if I'm going to call this point that I want xy, because why not? Or x naught. We already know this point. That's negative 5, 0. So I can say the slope is, I'm just going to call it y minus negative 5. Whoop, that's not the x value. The x or the y value is 0 over x minus negative 5. So it'd be x plus 5, I guess. So we can say that the slope of the line anywhere is y over x plus 5 in this particularly cool spot. So this is the other slope. And my thinking is we can match these up because this line and this ellipse will only equal at this spot. Is that not correct? So I think what we can do is we can put them together, and I'll say like negative x over 4y equals y over x plus 5. And then if we want to solve, well, we'll multiply up the denominators. So we'll do negative x times x plus 5 equals 4y squared. And I'd even like to expand that and maybe divide by 4 equals y squared. Because why not? You know? And maybe we can put things in here. What do we got? What do we know? Well, we know what y squared is, because it's equal to 5 minus x squared over 4, which is not the same as what we have here. So we have negative x squared minus 5x, and if we multiply the 4's up, they just cancel each other out, equals 5 minus x squared. So maybe we'll add the x squared over, and that goes away, and we get negative 5x equals 5. So that tells me that x equals negative 1 at this magic spot. And that's good to know because I can plug that into anything. We know that y squared already, so we'll do that. Y squared equals 5 minus x squared over 4. Well, we know that x is negative 1. So negative 1 squared over 4. That's 5 minus 1 would be 4 over 4. So our y value is going to be 1 here. And that tells us, so I'll put a y there, sorry, y equals 1. That on the ellipse, we now know that this is negative 1, 1. And that's useful because we can find the equation for this line, can't we? We can find the slope because we know 2 points. We know one point, I'll draw it here like this, is at negative 5, 0. And we know another point is at negative 1, 1. So what's the slope? Well, it's y2 minus y1, so 1 minus negative 5 over x2 minus x1. And that is a slope of 6. Is that right? y2. It is not right. I put that in the wrong order, didn't I? y2 minus y1 is 1 minus 0 over x2 is negative 1 minus x1. So that would be 1 over, what do we got here? Negative 1 plus 5 is 1/4. And we know y equals 1/4 x plus b, but we don't know the y-intercept yet. Let's plug in the values. So 1 equals 1/4 negative 1 plus b. So b is equal to 5/4. So this line should have the equation y equals 1/4 x plus 5/4. Now my question is, the original question way up here says, how far above the x-axis is the lamp located? So they want this here, don't they? So that is an x value of 3. We'll plug in 3 and we'll try to get the height. Okay, so if y equals 1/4 x plus 5/4, then it would be y equals 1/4 times, we'll circle that just to have it, 3 plus 5/4. 3/4 plus 5/4 is 8/4, which is equal to 2. So that means that this lamp right here is at the coordinate point 3, 2. And your answer for the height is 2. And that is the correct answer. So what we've done here is, just to recap, because you're going to take a test on this, right, is you're going to have, we found the slope to this line. We found the equation for this slope. We also found an equation for the slope of this. And the only time that the tangent line and the slope match is in this spot here. We just plugged in and found it. I think that's pretty neat.